Okay, so for this key, section 16.3 part A, we're solving, in this case, quadratic equations, and you need to use the quadratic formula. All right, and then it says show all work as presented in class videos to receive full credit. All right, so remember the quadratic formula is this. So first of all, if you're given a quadratic equation in standard form, remember, standard form is ax squared plus bx plus c equals 0. That's standard form. So if you give an equation, a quadratic equation in standard form, we can use the quadratic formula to solve this equation, to find the solutions to this equation. And so quadratic formula, if the variable's x, you would say the opposite of b plus or minus the square root of b squared minus 4ac. And the whole part here, that whole expression, is being divided by 2a. And so remember, a is a coefficient of x squared, b is a coefficient of x, and then c is your constant. All right, so in this case, this quadratic equation is in standard form. And so before we substitute the values of a, b, and c into the quadratic formula, let's determine what a, b, and c are. So in this case, a is 1, coefficient of x squared is 1. B is 9, coefficient of x is positive 9. And c is 20. Your constant is 20. And so we're going to just plug these values into the formula, and we're going to evaluate that formula. All right, so I get x equal. So this says the opposite of b. So in this case, b is a positive 9, so the opposite of a positive 9 is a negative 9, plus or minus the square root of, and then for this part, when we do the radicand, and remember this is called the discriminant, you're going to talk about that next semester, but when doing this part, put all the values in parentheses. So I'm going to put b in parentheses, so b is 9, so I'm going to say 9 squared minus 4 times a is positive 1, and then c is a positive 20. And all of that's being divided by 2 times a, and a is 1. All right, so the first thing you got to do is just plug all your values into the formula. Then we're going to simplify the radicand. We're going to simplify this discriminant. So I get negative 9 plus or minus the square root of 9 squared. 9 times 9 is 81. And just remember that b squared, whatever b is, if it's something other than 0, if it's a positive or negative number, b squared should always be positive. So never make this negative. This should never be negative. B squared should never be negative. Now the discriminant can be negative, but b squared should always be positive or 0. All right, then a negative 4 times 1 times a negative 20 is a negative 80. All divided by 2 times 1, which is 2. So just remember that this whole expression of here, make sure you do your division symbol from negative b, the opposite of b, all the way to the end of this radical. All right. Okay, so when we simplify the radicand, 81 minus 80 is 1, so I get negative 9, plus or minus the square root of 1 divided by 2. And you need to simplify as much as possible. So in this case, 1 is a perfect square. So the square root of 1, I can simplify. Is it exactly 1? So this becomes negative 9 plus or minus 1 divided by 2. All right, at this point, you need to understand that these solutions are roots. So we're using the word solutions, roots, mean the same thing. That these roots, these solutions are rational solutions. So these are rational. All right, rational solutions. So rational versus irrational. So the fact that the radical here, the square root of 1, that 1 is a perfect square and the square root of 1 is 1, I'm going to end up here with rational solutions. So once I get rational solutions, I'm going to rewrite this into two separate solutions, into two separate expressions. So this becomes, see with that plus or minus, you're going to say negative 9 plus 1 divided by 2. And then negative 9 minus 1 divided by 2. And so over here, that's a negative 8 divided by 2, which is a negative 4. And over here, that's a negative 10 divided by 2, which is a negative 5. So you have two solutions here, a negative 4 and a negative 5. So your solutions are x equal negative 4, x equal negative 5. All right. Now, if you have time to check, you can always check these, but just recall that on a test, you're not going to have time to go back and check all these solutions. But basically, you would substitute each of these values into the original equation, and you would see if the left side does equal 0. So for example, I'm just going to check negative 4 just to show you. So if I check x equal negative 4, if I check x equal negative 4 for number 1, I get this. I get negative 4 squared, x squared, so negative 4 squared, plus 9 times negative 4, plus 20, and I want to see, so it's a question mark, if that's going to equal 0. Well, negative 4 squared means negative 4 times itself, so that's 16. 9 times a negative 4 is a negative 36, and then plus 20. So 16 and a negative 36 is a negative 20, and negative 20 plus 20 does equal 0. All right. So, and if you did the same thing for negative 5, you would see that would work as well. Okay. All right, number 2. Now, first of all, in number 2, you have, remember, the first thing you got to do is make sure it's in standard form. Number 2 is not in standard form, so you have to rewrite it. So when we put it in standard form, we subtract 12 from both sides. That's what you're doing. And so you're going to have 3x squared minus 5x minus 12 equals 0. And again, make sure it's in descending order. So now we know that a is 3, coefficient of x squared. B is a negative 5. All right, so the coefficient of x is negative 5, not a 5, positive 5, a negative 5. And C is a negative 12. And so now we're going to just plug and chug. So we're going to plug these values into our formula, and we're going to find out what that expression is equal to, what our solutions are. All right, so we get x equal the opposite of b. So b in this case is a negative 5. The opposite of a negative 5 is a positive 5. Plus or minus the square root of. And remember the discriminant, we're going to put all this in parentheses. So I'm going to put in parentheses right here, b, which is a negative 5, but I got to remember that I'm squaring that, minus 4 times a is 3, times c, which is a negative 12. All of that, so notice I'm going from 5 all the way to the end of this radical expression, is being divided by 2 times a, so that's 2 times 3. So we get equal 5 plus or minus the square root of. And remember, b squared, that should always be positive or 0. So negative 5 times itself is 25. So not negative 25, a positive 25. All right, a negative 4 times 3 times a negative 12. So just use your calculator if you can't determine that. But if you look at it, negative 12, negative 4 times 3 is a negative 12. A negative 12 times negative 12 is a positive 12, positive 144. But all you have to do is just say negative 4 times 3 times negative 12 equals, and you get 144. So that's plus 144 all over 6. 2 times 3 is 6. All right, so then we get this. We get that's going to equal now. So I'm going to simplify the radicand. So we get 5 plus or minus the square root of 169 divided by 6. All right, at this point, you need to check and see if I can simplify the square root of 169. First of all, see if 169 is a perfect square. And it is, but if you couldn't tell right away, then just do this. Do second square root right here, 169. And if you get a whole number, which I do, then I can simplify the square root of 169. So 169 is a perfect square because I ended up getting a whole number. So that's going to become 5 plus or minus the 5 plus or minus 13 divided by 6. Now notice this, since I no longer have that square root, this is going to be a rational solution. I'm going to end up with rational solutions. So in other words, remember rational solutions, a rational number is any real number that can be written as a fraction, a over b, where a and b are integers and b is not 0, because remember we can never divide by 0. All right, so that would make it undefined. So b cannot be 0. So for example, some examples would read like -4/5. That's a rational number. I have an integer divided by an integer. 0.7, that decimal is a rational number, because recall, when you read this, that's really 7/10. Right, so any decimal, so remember that any decimal that terminates is a rational number, because you can always write it as a fraction. Any decimal that repeats is also a rational number. So for example, 0.6 repeating. Remember that 0.666? Well, that's just 2/3. All right, so any decimal that repeats is a rational number. Any decimal that terminates is a rational number. All right, and then the square root of 16 is a rational number, because I can write the square root of 16 as 4, and I can write 4 as 4 over 1. All right, so those are all examples of rational numbers. So this worksheet, by the way, when we discussed it, all the solutions here are going to be rational solutions. Okay, now once you realize that the 169 is a perfect square, then you're going to end up with rational solutions. So that's where we're going to split it apart like this, and we're going to actually figure out what each of those solutions are. So this becomes 5 plus 13 divided by 6, and then 5 minus 13 divided by 6. And so 5 plus 13 is 18 divided by 6, which is equal to 3. So one of my solutions is 3. Over here, 5 minus 13 is a -8 divided by 6, but go ahead and reduce this. Don't leave it as -8/6. Just go ahead and reduce. So that's going to be a -4/3. Okay, so so your two solutions are 3 and -4/3. All right, number 3. 3x squared minus 4x minus 7. Again, we wanted to solve these equations by using the quadratic formula. Now remember, always do the directions. If you did not read the direction very carefully and you factor these, now these are factorable because the solutions are rational solutions. So if the solutions are rational, this could have been factored. So if you got the solutions by factoring, you wouldn't get any points because you've got it. It says to solve the equation by using quadratic form. So always make sure you read the directions. But these are factorable, so you could have solved this by using factoring. But that's not what you wanted to do here. You wanted to use the quadratic formula. Look over here in the number 3. It's already in standard form. It's in descending order. So let's just go ahead and figure out what A, B, and C are. So A is 3. B is -4, and C is -7. So it does help to write out what these are. Now we're going to substitute these back into the formula. So I get x equal, all right, the opposite of B. So B in this case is a -4, so the opposite of -4 is a +4, plus or minus the square root of. In parentheses, I get B squared. B is -4. I'm going to square that. -4 times A is 3. And then C is -7. All that's being divided by 2 times A. So 2 times 3. Just make sure you go from the opposite of B all the way to the end of the radical expression. All right, now we're going to simplify the radicand. We're going to simplify the discriminant. So this becomes 4 plus or minus the square root of, now remember, B squared should always be positive or 0. So -4 times itself is a +16. So don't say that's a -16. It's a +16. All right, a -4 times 3 is a -12. So negative 12 times negative 12 times a negative 7 equals a positive 84. So that's 84. All over 6. 16 plus 84 is 100. Divided by, oops, that's a 4 right here. Divided by 6. All right, now, again, you want to see if you can simplify the square root of 100. You can because 100 is perfect square, so the square root of 100 is 10. So it becomes 4 plus or minus 10 divided by 6. So notice that you no longer have a square root, so that means that these are going to be rational solutions. These are going to be rational solutions, just like these were. So negative 4 is a rational number. Negative 4 divided by 1. Those are integers. Negative 5 is a rational number. 3 is a rational number. 3 over 1. 3 divided by 1. 3 and 1 are integers. Negative 4/3 is a rational number. Negative 4 is an integer and 3 is an integer. So these are going to be rational numbers. Rational solutions are your solutions, or rational roots. So this becomes 4. Once you realize that these are rational solutions, then you split it apart, because I want to know exactly what they are. What are those solutions? So 4 plus 10 divided by 6, and then 4 minus 10 divided by 6. So 4 plus 10 is 14 divided by 6 reduced. They're both divisible by 2, so it would be 7/3. Over here, that's a negative 6 divided by 6, which reduces a negative 1. So your solutions are x equal negative 1 and then x equal 7/3. All right, that's number 3. Number 4. All right, number 4, this time your variable is y, but it's not in descending order, it's not in standard form, so let's go ahead and rewrite this in standard form. So I'm going to subtract 8 from both sides, so I get 9y squared plus 6y minus 8 equal 0. And so now a is 9, b is a positive 6, and then c is negative 8. So now we're going to substitute this into the formula, so I get y equal. Remember your variable is y this time, so I say y equals the opposite of b. Well, b is 6. The opposite of b would be a negative 6 plus or minus the square root of b squared, so 6 squared, minus 4 times a is 9, times c, which is a negative 8, all divided by 2 times 9. So I get negative 6 plus or minus the square root of 6 squared is 36. All right, now negative 4 times 9 is a negative 36 times a negative 8 equals 288. So it's a positive 288. So I get 36 plus 288. All that's being divided by 18. So that becomes negative 6 plus or minus the square root of, all right, 288 plus 36. So your radicand is 324 divided by 18. All right. Now let's see if I can simplify the square root of 324. So first of all, let's see if 324 is a perfect square. So we're going to take the square root of that, square root of 324, see what we get. And it is a perfect square because I ended up with a whole number. So the square root of 324 is 18, because 18 times 18 is going to be 324. So I get negative 6 plus or minus this plus or minus 18 divided by 18. Now don't make the mistake and do 1 here. You can't do that because this is really negative 6 divided by 18 plus or minus 18 divided by 18. So don't reduce these without reducing this as well. All right, so don't reduce anything at all at this point. Just go ahead and say, all right, since these are rational numbers, since these are rational solutions, I'm going to rewrite this as negative 6 plus 18 divided by 18, and then negative 6 minus 18 divided by 18. And then again, don't reduce. Don't say 18 into 18 is 1 and say negative 6 plus 1, because that's not true. All right, you got to reduce negative 6 as well with this 18. But what I would do, what you really need to do is just say negative 6 plus 18 is 12, and then 12 divided by 18 reduced is, let's see, they're both divisible by 6, it'll be 2/3. So that's one of your solutions, is 2/3. Over here, negative 6 and a negative 18 is a negative 24. 4 divided by 18. They're both divisible by 6. So that's going to be a negative 4 4/3. All right, so your solutions are 2/3 and a negative 4/3. Okay? All right, number 5. Okay, this is already in standard form. So A is 2, B is 3, and C is a negative 20. Again, make sure that A, B, and C are correct before you substitute that into the quadratic formula, because then all of this will be incorrect. All right, so then we're going to say x equal the opposite of B. So B is 3. The opposite of 3 is a negative 3, plus or minus the square root of B, which is 3, squared. Notice I'm putting all these in parentheses, times 4 times A times C. All that's being divided by 2 times A, so 2 times 2. So it's going to equal negative 3 plus or minus the square root of 3 squared is 9. All right, a negative 4 times 2 is a negative 8. And a negative 8 times a negative 20 is a positive 160. So I get 9 plus 160. All that's being divided by 4. So that's going to equal negative 3 plus or minus the square root of 169 divided by 4. All right, now again, we got to simplify the square root of 169 if we can. So let's first of all see if 169 is a perfect square. So we're going to take the square root of 169, and I get 13, which is a whole number. So 13 times 13 is 169. So 169 is a perfect square. So I'm going to rewrite this then as negative 3 plus or minus 13 divided by 4. And notice that these are going to be rational solutions. So I'm going to rewrite this as two separate expressions. So negative 3 plus 13 divided by 4, and then negative 3 minus 13 divided by 4. And so negative 3 plus 13 is 10 divided by 4. And so that's going to be reduced. It's going to be 5 halves. So one of your solutions is 5 halves. Over here, negative 3 to negative 13 is a negative 16 divided by 4, which reduced is a negative 4. So there's the other solution. So your two solutions are 5 halves and negative 4. All right, and the number 6, this is not in standard form, so we're going to rewrite this in standard form. So when I put this in standard form, we get 4x squared minus 12x plus 9 equals 0. So be careful when you put this in standard form. So you're subtracting 12x from both sides, so that's how you get minus 12x, and then you're adding 9 to both sides, and so that's how you get plus 9. All right, now A in this case is 4, B is negative 12, and C is 9. All right, now we're going to substitute these values back into the formula. So I get x equal the opposite of b. So the opposite of negative 12 is a positive 12, plus or minus the square root of b, which is negative 12 in parentheses, squared, minus 4 times a. A is 4, and then c is 9. All that makes you go from 12 all the way to the end of the square root symbol is being divided by 2 times a, and a is 4. So I'm going to simplify the discriminant. I'm going to simplify the radicand. So I get 12 plus or minus the square root of negative 12 times itself is 144. A negative 4 times a positive 4 is a negative 16. Negative 16. And that's being multiplied by a positive 9. And so I get a negative 144. So this becomes 144 minus 144. All divided by 8. 4 times 2 is 8. Now notice what happens in this case. So this right here becomes 12 plus or minus the square root of 0 divided by 8. Now remember your smallest perfect square is 1. All right, so 0 is not a perfect square, but I can simplify the square root of 0. The square root of 0 is 0. So that's just 0 right here. So I get 12 plus or minus 0 over 8. But I want you to notice something. That 12 plus or minus 0, 12 plus 0, 12 minus 0, that's just 12. And so notice that in all the others, I ended up with two distinct solutions. They were not the same. Each equation had two different solutions. 2/3, negative 4/3, 5/2, -4. Whereas over here, I only end up with one solution. And one solution. So if I just split it apart, it would be this. You would get 12 plus 0 divided by 8, and then 12 minus 0 divided by 8. But both of those is 12/8, which reduced is, let's see, they're both divided by 4, so that's going to be 3/2. So you only end up with one solution. Don't write 3/2 twice. Just write it once, because that's the only solution you have. Now, this is really called a double root. You don't have to know that in here. But that's called a double, D-O-U-B-L-E, D-O-U-B-L-E, double root. So it occurred as a root twice. All right. So when you start graphing this next semester, you're going to see what each of those means. So just for your general information right now, so when see how I found these to be solutions, and I got those when this was equal to 0. So meaning that this value here, your y value, was equal to 0. those are going to be your x-intercepts next semester. So you can see how the graph looks in terms of these x-intercepts. Whereas over here, see there are two here, two x-intercepts here. Here, there's only one x-intercept. So you can see what that's going to look like. So since that's a double root, next semester, that's going to mean something in terms of the x-intercept. Okay, but anyway, so that's the end of this key. So that's the key to section 16.3, part A.